Hello, this is Valentina Angelova for Computer Science 480, and my presentation is going to be on Super Mario and AI. Super Mario AI implementations use a version of Marcus Parsons' Infinite Mario Bros., which is a public domain clone of Nintendo's classic platform game Super Mario Bros. The original game is playable on the web, but the Java source code is available for download and has been used heavily to be modified to create AIs. The gameplay in Super Mario Bros. Consists in moving a player-controlled character through a two-dimensional level, which is viewed sideways. Mario can walk and run to the right and left, jump, and depending on the state that he's in, shoot fireballs. Mario can be in one of three states: small, big, and fire, in which case he can shoot fireballs. The main goal of each level is to get to the end of the level, which means traversing it from left to right. In 2009, Sergei Karakovsky and Julian Togelius held a competition to develop the best controller agent for Infinite Mario. The controller's job was to win as many levels as possible while reacting to the environment. The winner of the competition was Robin Baumgard. His submission was surprising because it only used a simple implementation of the A-star search. The implementation was faster and better than evolutionary learning approaches because it was taught to travel forward without getting hurt as fast as possible. The search finds the optimal path going forward. Mario uses a grid to detect what's right in front and behind him and avoid obstacles as he moves along. As you can see on the screen, the red line that is shown is the A-star search's proposed optimal route. This AI outperformed other submissions significantly since it didn't have to learn how to play, but instead used a heuristic to get through the level. Robin Baumgarten won the Mario competition using a very simple A-star agent, and I'm going to walk you through some of the code just to give you an idea of how easy it was to do this. So to play in the competition, you had to extend an agent, or at least all the entrants extended an agent and created their own. So here we're using an A-star agent, and it actually creates an A-star simulator. So this is where the bulk of the logic lies. So the A-star simulator has the search algorithm, which is very similar to the search that we would have done in assignment 1. It has nodes, and it calculates a heuristic. So here's the search method. We start off by checking to make sure that while our position pool is not empty, we're going to go ahead and search for the best position. And here is the function that picks the best position. And if we look in there, you'll see the algorithm that was implemented. So for each position, so for each node in our list of positions, we go through and see if the node has a better cost. So here what's happening is we get Mario's position and we calculate the current cost. So the heuristic for the cost that was implemented was the current time plus the time elapsed plus a jump modifier, which gave it a slight bias towards finding the furthest position on the board. So this heuristic allowed Mario to move as fast as possible through the level. And then if the current cost that we calculated for the node is less than the best cost, then we found our best node. So as you can see, this was very similar to what we did with our 8 puzzle in looking through to find the best next possible position. A group of computer scientists from the University of Tübingen in Germany used an adaptive learning AI approach to bring Mario to life, sort of. So the living and conversing version of the agent was recently generated as part of the Mario Lives project, which was created for a video competition organized by the Association for the Advancement of Artificial Intelligence, which is a nonprofit scientific society that aims to showcase how much fun AI is by documenting exciting advances in the field. The idea behind this particular project was to develop an artificial agent who gets to know and thus becomes alive in a sense in his own world. Mario is aware of his environment, at least to some extent, and can understand a large variety of sentences, answer questions, learn, and even make decisions based on how he's feeling. The group has represented him as curious, which allows him to explore the environment, as well as hungry, which means that he goes in search for coins.
Listen, Goomba dies when you jump on Goomba.
Yes, I got that.
What do you know about Goomba?
If I jump on Goomba, then it certainly dies.
Mario's knowledge representation consists of conditions such as the actor, Mario, and the target, Goomba. Actions such as direction from above, which leads to the effect of the action, such as object destruction of Goomba. Along with these is a certainty estimate, which happens to be 1.0 in this case. Given this knowledge, grammatical sentences are generated by parsing the relevant tags of knowledge and generating a sentence that follows natural speech. The implementation made use of Carnegie Mellon's Sphinx Toolkit for speech recognition. Thank you for watching. If you have any questions or comments, feel free to reach out to me at my email address displayed on the screen.